Welcome to our roundtable with the title Outpace Competition with Integrated Supply Chain Execution. With a picture in the background, we are setting the stage for what we will be talking about in a few minutes. Supply chain execution for us means manufacturing, warehousing, yard logistics, and transportation. Let me highlight a few of the challenges we face in this context. A much higher level of agility is required to manage disruptions in a chain with a minimum of safety buffers to be prepared for unforeseen events. The importance of e-commerce is increasing also in business to business, and so is the demand for smaller, individualized products resulting in smaller order batches, which in turn requires a high level of accuracy. Regulations are forcing additional processes for product validation and sustainability. Similarly, full traceability beyond the company level is required by customers and regulators to derive the original raw material suppliers and product conditions at every step of the chain. Last but not least, real-time visibility is needed to detect any anomalies in the tightly timed flow of the chain. This is reflected in the picture by the layer of control towers and similar systems. Now, let's dive into this and let me briefly introduce the participants. Matthias Hollenders, our global lead for Industry 4.0. Vanessa Mitteregger, who is managing our warehouse practice in Europe. Matthias Platzer, one of our senior experts in yard logistics. Nicolas Daum, practice director, transportation and logistics. And myself, Martin Weiss, responsible for our operations in Europe. My first question goes to Matthias. Matthias, what challenges do you see when looking at an integrated end-to-end process from a manufacturing point of view?
Yeah, I think you already mentioned some of these challenges already in the intro. So it's clearly the topic of lot size one, or the production of smaller batches with high variations. So this requires then no longer the supply of larger quantities into the production line from the warehousing side, but really now dedicated parts that need to be provisioned to the manufacturing processes to really produce that individualized product. Mm-hmm. And also when we look at the exceptions that might occur, we need to in a flexible and agile way react to any unforeseen event. For example, a non-conformance being reported on the manufacturing side, meaning that, for example, there's certain defect in a certain product that has been produced. This individualized product then requires an immediate resupply of a small quantity from the warehouse. So the warehouse needs to be super agile and super fast in really providing this one specific material that is required. Or let's say also exceptions on the warehousing side, where it could be that the warehouse worker is picking a quantity, bringing this to the assembly line, but there's a mismatch towards between basically what he confirmed and what he actually put there. And so again, during the assembly, these mismatches will be detected, and leading then to a need for an emergency resupplies, kind of. Yeah. So we also see then on top of this the trend of customer orders kept open for a very long time, meaning that last minute changes for customers are allowed. And this again leads to an agility and flexibility between warehousing and manufacturing, because if there's a last minute change, the production line needs to be changed last minute, or the setup of the production orders needs to be adjusted. And also the warehouse system now needs to completely replan the orders that were already pre-planned based on a previous setup of this customer order. So again here, a tight alignment and basically breaking down these holistically two different domains of warehousing and manufacturing, and making this one domain is really key to really achieve this accuracy, flexibility, and agility. And on top, we also see then these continuous improvement initiatives where of course, there's a necessity to reduce buffers and inventories. Again, this can only happen when we, in that case, have those two domains properly working together as one.
Okay. When we look beyond this tight integration of warehousing and manufacturing, where in the yard and transportation domain do you see a similar need for this tight integration or interplay?
So, of course, also transportation and yard operations have an impact on the manufacturing itself. Now, looking at, for example, the outbound side. On the outbound side, production planning should consider, for example, transportation capacities or yard capacities in the end. Because we want to ensure that the size of a batch fits that truck, fits that container, etc. So that we're efficient in basically delivering customer orders, that we're efficient in basically reducing stock levels, etc. Same similarly on the inbound side, we are dependent on yards and transportation operations to give us insights with this just in sequence, just in time processes. We are dependent on an in time, in quality delivery of certain products. And if we, for example, see during the transportation execution, there's a delay of a ship, of a vessel somewhere, there's delay of a truck, it might be that during the yard operations, there's something happening, there's an accident or a traffic jam. We need to get to know these information into the manufacturing system immediately, because we need to then dynamically and flexibly and in a flexible way adjust to any unforeseen event reported by the system. And this only works if we are properly working as kind of one system in the end, one execution system end to end. And I think I forgot just one thing regarding warehouse. Again, so what we see is also many customers producing or tailoring a product in the warehouse or giving it a final touch in the warehouse. And this means that the warehouse is in the end doing small manufacturing processes. So again, here, the warehouse system and the manufacturing system need to act as one, because they're tightly working together in really producing this final finished product for the customer that's then being supplied to them.
Okay, that's a good handover to Vanessa for warehousing. What is your take on that?
Well, I definitely see the need that we have to adapt to these changes. I think many of our customers are in very competitive market situations and really have to rethink their concept on how they can outpace their competition. And I think our job is to help them understand how they can leverage the software, SAP in this case, and not only focus on, let's say, basic processes. I think we should really focus on innovation and integration and help them define their roadmap maybe to a new system landscape, to S/4HANA, and really leverage as much as possible the capabilities that this brings with it. So I think, as Matthias said, customers will demand maybe a lot more in the future than it might have been in the past. So we just need to think of how can we speed things up? How can we automate as much as possible so we don't have to worry about basic processes? And how can we keep this flexibility and maybe give products a final touch in the warehouse, maybe adapt to changing packaging requirements in a very last minute, and just deliver all the arguments to really help the customers to outpace the competition. So looking at warehousing and production, I think AGVs is a big trend topic that we followed over the last couple of years. We've seen many implementations happening, because I think this goods to man principle is really something helpful especially when it comes to production, manufacturing, and warehousing. I think another topic that comes to my mind when I think of tight integration is maybe the freight monitoring in the yard. Yeah. So when a truck arrives and we expect the goods to have a certain temperature, why not use sensor data to give us the information? Okay, this load has a higher temperature than we would have expected it, and have the system push this information to us, and not doing everything manually. So let the system tell us that we have to run a special quality cycle, not run the regular process if everything would have been as expected. And I think the real benefit here is that we have the possibility to have it all together in one system. We don't have to have, if we don't want to, external systems, interfaces. It can all be in one place. It can all be in SAP.
So the keywords here are transparency and inspections, some of the keywords. What requirements need to be met from a transportation preparation perspective?
Well, I think there are a lot of inspections and checks going on both in the warehouse and in the yard. I mean, pretty much everyone involved is somewhat liable for example, securing of cargo before it leaves the yard. So, looking back to the old days, or probably most customers still do it this way. There's a lot of manual stuff going on, people having their paper checklists, walking around, checking everything, maybe taking pictures. So just to make sure it's documented that everything is really secured. And in case of any liability question, information has to be stored, often still in a manual way, where papers are put away, maybe in file cabinets. Then you have to keep them for 10 years, whatever, yeah. So I can just see people walking around with the handheld, with the mobile device, maybe a tablet, and doing all of this in a digital way, yeah. Having the data directly in the system, not manually floating around somewhere, maybe also taking the picture directly with this tablet, yeah, and having it in SAP, all archived, so that there's no issue. Should it be the case that there's a liability question, you can just go into the system, pull it out, and have it all in one place.
So it sounds like digitization is a major pain point in the transportation preparation process, right? But in comparison to the other stages of the end-to-end supply chain, where is the room for holistic improvement in the execution process? Matthias, please.
Yes, exactly. So if you want to have an integrated, optimized end-to-end supply chain in place, you need to close existing gaps in your digitization. And let's review the current situation. So we have seen warehouses run by IT solutions for years now. Some of them are fully automated, backed by IT solutions. In transportation, we would see a digital transportation planning and transportation execution process. The remaining gap in between is still the area between the public roads, between the public railroad tracks to the warehouse, the so-called yard, the transshipment point. These yard processes are even today outdated and paper-based, meaning that if there is any IT solution in place or any digital process in place, it would be a digital planning in a spreadsheet, but that's it. And it's obvious you cannot outpace competition if you have such a tremendous gap in your digitization. Yeah. So first of all, you need to close this gap. You need to implement an IT solution for your yard processes. Yeah. This would give you, in the first step, access to digital labor distribution. Talking about labor distribution, it would be that in a central office, jobs and tasks would be planned for the people outside doing the jobs and tasks then in the yard. And the people there would document and log the fulfillment of these tasks in mobile devices, using tablets, using handhelds. Secondly, this would give you access to contactless processes. And in times of COVID, this is crucial. And yes, of course, just with the digital process, you would have access to monitoring capabilities and to reporting capabilities. But this is just the first step. The second step is, if you have this digital process in place, you can start to automate this process. You can start to automate certain process steps. You can start to automate certain sub-processes by using OCR technology, by using sensoric data coming from sensors in the yard, and by actually integration to the infrastructure in the yard. And once you have this automated, optimized process in place, yeah, your yard's performance would increase, your yard's throughput rate would improve, yeah, and this would lead that your overall supply chain's performance will improve significantly.
Okay, we learned a lot now about integration between manufacturing, warehousing, the yard. But if we look at the road to an improved end-to-end supply chain, where can we see other integration points between, for example, the warehouse, the yard, the transport preparation, the transport execution?
This is another important trend over the last couple of years, the exchange of information between warehousing and yard operations. And actually, dock appointment scheduling comes to my mind. Yeah? Let's review the history here. Yeah? For centuries, trucks or any means of transportation, any transport equipment arrived to the warehouse without any type of B notification. Yeah? So you can imagine the traffic jams in front of the check-in, you can imagine the congestions in the lanes in the yard to the warehouse, and you can imagine the congestions in front of the warehouse doors. And this would also lead to either idle times for the warehouse staff or an overload of work. Yeah. So first thing to do here, yeah, you need to interface or to hand over information, yeah, basic information from the shipping and receiving department to the warehouse. Yeah, with this input of just basic data like planned loading date, yeah, like planned pickup date. And the type of cargo, for example, that needs to be shipped or received. Just by this basic information, the warehouse can start a rough planning on warehouse lane level. Yeah? The second step here is that yard operations need to introduce a mandatory time slot booking. What is a time slot booking? A time slot booking would be that an external party, the external carrier, the external operator of the inbound transportation would select a time slot out of a range of available time slots. With this, you would just reduce the arriving trucks or arriving means of transportation to a manageable quantity per time period, usually an hour. And this would be then a planning input for the warehouse, yeah, a second planning input, not only the loading date, but also the arriving time, yeah, to the yard, which means the warehouse could perform a detailed planning on warehouse door level, on warehouse lane level, yeah, and the warehouse could determine already the warehouse door. And this information should be handed over back to yard operations. And once the transport equipment arrives to the yard, this door is just assigned to the transport, and the truck would directly go to the warehouse door. But this exchange of information just not only happens between warehouse and yard operations, but also between transportation and yard operations. Yeah, in transportation planning, you would have an optimized routing of trucks. Yeah? This optimized routing includes actually a planned time of arrival to the warehouse, to the yard. Yeah? Let's call it the estimated time of arrival. And this estimated time of arrival is constantly updated during transport execution. Okay. And if this is handed over to yard operations, we could just use this information for the arrival planning, for a holistic arrival planning between transportation and yard operations, and then later on also for the warehouse. This arrival planning would give you total control over your incoming and outgoing traffic, over your inbound and outbound transportation to the warehouse.
Okay. Now, looking a bit more to external logistics of companies, Nicolas, can you please elaborate a bit more on the challenges you and your customers face in this external processes when it comes to interconnections and touch points?
I will focus a little bit on the question, what is naturally required to have full control of seamless in and outbound processes, namely goes with an interlinking of the upstream, as we have heard, and downstream processes. So from a pure transportation perspective, we talk about connecting our warehouse processes, connecting our manufacturing processes, Matthias has just mentioned, or Matthias Platzer about the yard. I'll give you some examples from the real life. So what we see, what we saw over the past years is that the direction of customer demands has developed in a direction where we have, on the one hand side, as Matthias mentioned, smaller sizes, custom-made products. On the other hand side, we have flexibility in the time windows, meaning same-day delivery. We all know that the terminology is same-hour delivery, which is in urban logistics the case. Another example is hyper-local sourcing of goods, meaning the goods directly from the suppliers in the area where we have to deliver. This interaction between the warehouse here, the hub operations, and the TM system is crucial and is required. So if we talk about now, how do we get this? How do we get to this point, and what's the challenges? Is definitely take the leap here and go into the S4 HANA transformation and development. What we see here is that companies which are not following this approach, interlinking, connecting processes internally, from all these different aspects we have heard, are having tremendous more effort in terms of keeping the actual amount of reasonable processes within their process. That means just simply getting more loads, more capacities throughout the day, bringing more resources in the warehouse, to keep that stabilized, and that's basically it.
Okay. Back to Matthias. If we look at all the domains, what topics do you see that span across all these domains?
So all the domains, I think we already mentioned some of these topics. So it's really the planning and scheduling. Because this planning and scheduling needs to happen across the entire chain. It needs to involve the manufacturing planning, production planning, needs to involve the warehouse planning, the yard logistics planning, and also the transportation planning. And when we look at it from a manufacturing point of view, as I mentioned already, the production of quantities that fit a certain size of a truck, for example, is really something that is key. So we need to know during the production plan, okay, what kind of capacities do I have available on the yard, on the transportation side, to really basically load them into them, and make sure that I deliver one full truck instead of just partial loads. And of course, we also need to consider then the warehouse capacities. We need to consider labor qualifications and so on, to also plan on that side, because we're dependent on the warehouse to supply material. We need the warehouse to pick up the material of the kind of finished products that are being produced from a manufacturing point of view, that then need to be again put back into the warehouse before it's getting loaded. So again, here, this planning and scheduling for manufacturing into the entire chain is super critical. Similarly, also from the warehousing side, we see that warehousing again is getting input from manufacturing. At what time, what kind of quantity is required at the assembly line, and at what time and what quantity is the finished product available to be kind of brought back into the warehouse. But also warehouse needs to know from transportation and yard logistics when is a load to be expected, so that they can plan accordingly. They need to know what kind of packaging material is coming in. Do I need to unload pallets? Do I need to unload odd size boxes, etc. So this is something the warehouse needs to properly plan then all of the activities on the inbound side. So this means these domains, all of these 4 domains here, we need to work together to plan and schedule all of the activities, to no longer mitigate risk by increasing buffer levels, etc. Really by running a lean and efficient production, manufacturing, warehouse and yard operation logistics. But I think when we look at also the operations, probably you, Matthias, have a few more topics to add here.
Yeah, exactly. So this is going into the same direction, which I briefly mentioned before, with the total control over inbound and outbound traffic. But actually, in my example, there was just the 3 stages integrated. So the warehousing, the yard operations, and the transportation. But when adding now this 4th stage, the manufacturing, this would actually lead to a whole new concept of just-in-sequence production. Yeah, if all the 4 stages of the supply chain network are planned with the same input, yeah, this would be total control over the flow of goods there. Meaning that this would be a holistic capacity planning throughout the stages. So every good to be manufactured, every move in the warehouse, every stock, every cargo on stock, and every move in the yard, and every transportation would be based on effective production requirements. So this is a whole new concept of holistic capacity planning then.
Okay. Now, Nico, sorry, from purely operational point of view, how will the future of supply chain operations look like?
Interesting topics you just mentioned. From a pure future business of operations, what we definitely see is that the innovation, and let me make that point first, that the innovation is coming from the business processes itself. The technology we just described is only catalyzing this and speeding up the implementation. So having heard now what's going on in the production line, in the warehouse, in the yards, the question is, how do we bring that together in one concept for an holistic user interface, yeah, where all the different involved parties, the ladies from the warehouse, yeah, the guys from the yard, yeah, the planners, the dispatchers from the transportation management, where everybody works in one single source, yeah, and we can really call it single source. And this technology is available. We call that supply chain control towers, yeah, where we just put the pieces together here. Take the EWM side, take the yard side, take the production line, take the TM side, and then really following the Pareto principle on the 80% business we have throughout the day, yeah, where everything goes right, yeah, we don't need to interact and react on. Yeah. If we talk about predictive and prescriptive capabilities of the system, which are there in 2021, we're talking about what can be proposed and instrumentalized from the system to make the end user's life in a day in a life scenario easier, yeah, to get proposals in there, to react on that proposals, on that exceptions, yeah, and just simply work on that 20%. How can we achieve this? Yeah, we have heard throughout all processes here with an automation degree around 80 to 90%, yeah, and then just bringing the results, visualize them into that control tower.
Okay. So that's good insights about the internal processes and internal data flow. But how about the external data we are receiving, for example, from logistic service providers? How do we deal with that?
That's another puzzle piece in that chain. Yeah. So we have heard about the internal processes, the internal modules, let's call it. Yeah. Given the fact that real-time transportation visibility, so RTTV providers are spreading from the ground here, such as Project 44, giving us another puzzle piece and data into our supply chain. Yeah. So the question is, again, as I said, in our holistic concept of an business of the future operational tower, this piece from the outside world, from the external world, has to be brought into that as well. Yeah? The good thing here is that these connections to those providers within the SAP technology platform are natively integrated. So we can receive the signals, the milestones throughout the transportation chain in there and get it back reflected into our portal. So now just the question of, are you taking this leap to go? Because the technology is there. That's the good news provided by our friends in Walldorf, and we have just to implement that in the end.
Okay. Thanks to you all. I think we have touched upon some very important topics of this pretty diverse domain of supply chain execution. Let me summarize briefly. To meet the challenges, companies must be able to rely on state-of-the-art supply chain IT solutions as their backbone, and these solutions are readily available. Those that take full advantage of these state-of-the-art solutions gain a massive competitive advantage and outpace the competition. Now, we're in for some questions. I will check the chat later, but questions we gathered before this presentation or discussion. One question that goes to Matthias more, to the manufacturing context. If we look at SAP systems or in the SAP context, where do you see the manufacturing application? We are currently evaluating the SAP applications to replace our non-SAP MES system and are faced with multiple options. So that would be...
Yeah, so I mean, we and together with our customers, we are now mainly looking into this integrated flows. Yeah, I think now selecting the right system means also selecting a system based on the integration capabilities. Yeah, so ensuring that now talking about manufacturing, as that was a question, we need to ensure that the warehousing can be properly integrated, and that we can properly integrate to a yard or transportation management system. So this is one of the key criteria that needs to be evaluated, and this is where we and our customers currently see definitely from SAP point of view the digital manufacturing cloud. Yeah, so the DMC. So this is the tool or the application that we are currently looking at heavily. It's a cloud-based tool. So also kind of a future-proof solution which has a big investment and very, very strong roadmap behind from SAP. And it's basically also replacing, the question also mentioned multiple other SAP systems. So of course replacing what MRI or SAP ME is providing with covering process industries or discrete industries. The DMC combines basically all this. Yeah, it combines what these solutions provide from an MES, so manufacturing execution point of view, plus it adds on top certain additional capabilities of providing insights, insights across multiple plants, giving kind of standard KPIs to measure the performance of all the plants globally, to have one unique set of KPIs. Also have the idea of an insight to action, so to run prescriptive, to not only analyze data and get KPIs on how the manufacturing systems or production is performing right now, but also to go the step beyond that, to identify, okay, what can be done, what kind of errors do we expect, and how can we mitigate those errors and risks, and that we could foresee. So this is one part, and really triggering then activities in the respective systems, but also closing a gap with that DMC of what we have seen of the short-term planning. So scheduling of labor, of equipment, production orders, all on interactive dashboards, and really solving this gap in the SAP space, where so far we couldn't really optimize on an operational kind of shop floor everything that is happening with pop-ups, informing about any incidents happening with an immediate way of just solving those issues via drag and drop capabilities. So I mean, if currently SAP systems in terms of manufacturing are being analyzed clearly from our point of view and from the view also of the discussions that we have with our customers, we should really look now into this digital manufacturing cloud.
Okay. Now, another question regarding embedded solutions embedded into in SAP S4HANA. Question to Nico. What about embedded transportation management in S4HANA?
One important component, we have a lot of requests and market demand to bring that into an embedded scenario, especially for those customers not in an S4 environment so far, and with the lean, let's say, transportation demand from a pure operational perspective. There are advantages, definitely, if we think about only the integration perspective within the systems, you less interfaces in there, The biggest aspect I see, especially when it comes to embedded scenarios, is that you have all the insights you need in one box, and you need to know what's going on during the day. And with this titles integration, you got that information. And that's one of the biggest pieces.
Okay. Similar question to Vanessa. What's the main pros and cons to embedded EWM?
I think in the context of EWM, everything that Nico said applies as well for the embedded scenario. But in general, I think in warehousing, that's a much wider discussion because first question that usually needs to be discussed or clarified is, especially, of course, when we speak about automated warehouses, is the embedded scenario really the one that's applicable, or does it have to be at least for maybe, for example, a big distribution center with loads of automation, do we have to go decentralized? So that's most of the times one of the main aspects. Of course, we have a lot of customers that have, let's say, global programs. So we're not speaking of one warehouse. Often we speak of a variety of warehouses, maybe a couple of them no automation at all, or also depending on the on the country or the region where we can maybe bundle a couple of them. So I think that that's one point in the context of EWM. The other context is how far are customers with their S4 roadmap in general? Yeah, do we already have an S4 box where we can start with a small, maybe smaller warehouse with embedded EWM, either basic or advanced? Is there something in that box we can embed it to already?
Yeah,
so we need to figure that out. So there's it's a wider discussion for warehousing,
Okay.
I think.
Good. One question goes to yard logistics. Can external employees, for example, truck drivers, be involved in the documentation of the transport preparation process?
Yes, of course. Let's stick to the example of the truck driver. I think that's the easiest one. Actually, truck drivers are already involved in the documentation of the transport preparation process. So it would start with an active involvement during registration of the truck at the gate from the yard or from the warehouse, meaning that the truck driver would actively give contact details, license plate, trailer, truck and trailer combination, and so on and so on. This is an active involvement. After that, it would most probably be a passive involvement. So you need to guide the truck driver from the gate to the loading point, to the unloading point. This you can do by just signs, just some SMS communication, some digital communication pages handed over. But this is still a passive involvement. It gets complicated when you want to actively involve the external party in logging process step confirmations, in logging just progress on the yard. Because what is the motivation for the external party to log your performance, to log your system? And therefore there are some examples in dry bulk and in liquid bulk scenarios where the loading would be with a self-filling, with a self-loading. So the truck driver, he or she needs to actively press buttons to get the cargo. And this would be the motivation for the external party to be involved in your process. And this is actually one easy example for this. We could go on and on with this, but I think the question is answered.
Yeah. Thank you very much. I think there are no more questions. We're coming to an end. Thanks to all of you who participated in this roundtable.